So millions of people are walking out of their doctor's office today with like a generic prescription for exercise.
Right.
But a massive new meta-analysis actually reveals that for a very specific group of patients, just, jumping on a treadmill might be solving yesterday's blood sugar problem while completely ignoring this hidden structural collapse that's happening inside their bodies.
Yeah, and it is a profound disconnect in modern medicine. I mean, we treat exercise as a monolith, but prescribing generic exercise is, well, it's like a physician handing you a blank pill bottle labeled medicine without specifying the compound or the dosage or, the actual biological target.
Exactly. And when you are dealing with a metabolic crisis, precision is literally everything. So that is the mission of today's deep dive.
Absolutely.
For you listening, if you or someone you know is navigating the overlapping challenges of diabetes and obesity, we are dissecting the data to answer a massive question. What is the single most effective way to exercise?
And we finally have the data for it.
We really do. We are looking at a landmark paper that finally pits aerobic exercise against resistance training in a head-to-head scientific matchup.
The scientific community has been waiting for an analysis of this caliber for, well, a long time.
Yeah.
Previous meta-analyses often just compared exercise to a control group sitting on the couch, which, doesn't tell a clinician what to actually prescribe. Or they relied on data from 20 years ago before modern pharmacological treatments completely changed the baseline of patient health.
Right. The landscape has changed. So let's give you the exact source material we're working from today.
Good idea.
The article is titled Comparative Effectiveness of Aerobic Exercise versus Resistance Training on Cardiometabolic Health in Patients with Diabesity, a systematic review and meta-analysis of randomized controlled trials.
Quite a mouthful.
It is. It was authored by Badri Al-Mhanna alongside a large international team of researchers, and it was published in the Journal of Sports Science and Medicine, Volume 25, on September 1, 2026.
And what makes this specific review so powerful is the highly focused inclusion criteria. I mean, they isolated data from 23 randomized controlled trials.
Wow.
Yeah, involving 1,184 patients who specifically have concurrent type 2 diabetes mellitus and excess adiposity.
Yeah.
We're talking about a very specific modern patient profile here.
Okay, let's start right there with the term the authors use in their title, diabesity.
Right.
Because before we can figure out the most effective treatment, we have to, deeply understand the pathology we are treating. This isn't just some catchy medical portmanteau for having two separate conditions that happen to occur at the same time.
Not at all. And treating them as separate issues is exactly why standard care often fails these patients. Diabesity represents a shared, deeply interconnected disease mechanism.
Right.
It is a specific subphenotype. It's characterized by this triad of issues: severe insulin resistance, chronic low-grade systemic inflammation, and ectopic and visceral fat deposition.
Ectopic fat, meaning
Fat isn't just being stored in standard subcutaneous tissue under the skin. It's being deposited directly into and around your vital organs, like your liver and pancreas, places where it absolutely should not be.
Okay, let's unpack this for the listener, because it's like having a flooded engine in a car that also has bad fuel.
That's a great way to put it.
Right. One problem constantly compounds the other, causing a vicious cycle of oxidative stress and atherogenic dyslipidemia. So why does standard fragmented disease-specific care fail so badly for these patients?
Well, if we connect this to the bigger picture, this vicious cycle of systemic damage is exactly why the American Heart Association recently formalized a new diagnostic framework. They call it cardiovascular kidney metabolic syndrome, or CKM syndrome.
Oh, okay.
Yeah, because your heart, your kidneys, your metabolism, they aren't operating in isolation. They are all relying on that same blood vessel network that is actively being damaged by the bad fuel and the flooded engine.
So diabesity is basically the gateway to this.
Exactly. Diabesity fits right into the early stages of this interconnected web of systemic dysfunction. When a patient sees an endocrinologist for their blood sugar, and then, drives across town to see a cardiologist for their blood pressure.
And then maybe a nephrologist for their kidneys.
Right. They are getting fragmented care for a unified problem. The authors of this paper argue that we desperately need a network medicine approach. We have to deploy interventions that target the shared mechanisms across all these systems simultaneously.
Which brings us to the ultimate systemic intervention exercise.
The ultimate medicine.
Yeah. So let's look at the data from these 23 clinical trials. It gives us a really fascinating demographic snapshot. We are looking at adult patients aged 30 to 70.
A good wide range.
With an average body mass index, or BMI, of around 32.1 kilograms per square meter.
Okay, so firmly in the obesity category.
Exactly. And the meta-analysis revealed a major finding right out of the gate for aerobic exercise.
Let's hear it.
So cardio was demonstrably superior at reducing fasting blood glucose. It showed a mean difference of negative 0.89 millimoles per liter compared to resistance training, and it also significantly increased cardiorespiratory fitness.
And those are two incredibly vital targets, especially in early CKM syndrome management.
And really?
Oh, yeah. Cardiorespiratory fitness reflects how efficiently your heart and lungs can transport oxygen to your working skeletal muscles. Reduced aerobic capacity is independently associated with a significantly worse prognosis in type 2 diabetes.
Wow.
So when you force a patient onto a treadmill, you are forcing their mitochondria to adapt. They multiply and they become far more efficient at utilizing whatever oxygen makes it through those damaged blood vessels.
Wait, hold on. I have to push back here for a second because looking at this data, there's a huge discrepancy.
Oh.
Yeah, if aerobic exercise is so great at lowering fasting blood glucose, why didn't it also win out on HbA1c, the long-term blood sugar marker? I mean, it seems like it should be a clean sweep.
That is such a good question. And it highlights a fundamental physiological dissociation in how our bodies process energy.
Okay, lay on me.
Fasting blood glucose and HbA1c are measuring two entirely different things. Fasting blood glucose primarily reflects short-term hepatic or liver glucose output.
Okay.
That is the sugar your liver actively releases overnight while you sleep.
Yeah.
Cardio acutely depletes your liver's stored glycogen, so you drain the liver's tank today, and tomorrow morning its output is lower.
Oh, I see.
But HbA1c integrates average glycemia over several months.
So it's a historical record, not a snapshot.
Exactly. And that long-term average is heavily influenced by variables outside of the gem, specifically the patient's baseline and the intense pharmacology, the medications they're already on. Over 3 months, those meds can easily wash out the subtle differences between cardio and weights.
Okay, that makes sense. But still, rebuilding the heart's fitness and dropping that daily fasting glucose is huge.
It absolutely is critical.
But here's where it gets really interesting.
I know where you're going with this.
Yeah, because if you just stop at cardio, you're missing the hidden danger we talked about earlier. The meta-analysis found that resistance training lifting weights definitively beat cardio in two crucial areas: preserving fat-free mass, which is muscle, and improving overall body fat percentage.
And this is where we have to talk about sarcopenic obesity.
Sarcopenic obesity.
Right. It's the dangerous, progressive loss of muscle mass and muscle quality that often accompanies obesity and diabetes. People think, well, if you're heavy, you must have strong legs from carrying the weight.
Right, that's the assumption.
But the chronic inflammation of diabesity actively degrades muscle protein synthesis. You're gaining fat while losing your structural engine. And skeletal muscle isn't just for moving around, it is an active endocrine organ.
Wow, an endocrine organ?
Yes, it is responsible for the vast majority of insulin-stimulated glucose disposal in the human body.
Okay, so what does this all mean for you listening? Let me try another analogy here. If your bloodstream is a highway flooded with sugar, your skeletal muscle is the biggest parking lot.
I love that.
If you lose muscle mass, which cardio doesn't necessarily prevent, by the way, you lose parking spaces, and the sugar has nowhere to go but stay in the blood.
That is a perfect analogy. You are literally demolishing your own parking lot, which is why resistance training is absolutely essential when the primary therapeutic objective is preserving that metabolic parking space.
It's building more spots.
Exactly. The physical contraction against heavy resistance forces glucose uptake into the muscle cells independent of insulin. You are bypassing the broken receptors entirely.
That is so cool. Okay, so we've seen that aerobic exercise and resistance training each win in specific, distinct physiological categories.
Right.
Cardio gets the fasting blood sugar and heart fitness. Weights get the muscle preservation and body fat percentage.
Right.
But what about the metrics patients usually care about most, like overall weight loss or blood pressure?
What's fascinating here is the tie.
The tie. Yeah, this blew my mind.
All right. For the majority of cardiometabolic outcomes, body weight, BMI, waist circumference, blood pressure, and blood lipids like cholesterol, the meta-analysis found no statistically significant difference between cardio and weights.
They both work equally well.
They do. And this completely dismantles the one-modality-fits-all model of exercise prescription. You don't have to just run on a treadmill to lose weight or lower your blood pressure.
Right.
It introduces this concept of exercise as a pleiotropic polypill.
A pleiotropic polypill, meaning a single treatment that creates coordinated adaptations across multiple body systems, right?
Precisely. A single behavioral intervention improves your lipids, your blood pressure, your endothelial function all at once.
That's incredible.
But the ultimate conclusion of the study is that prescriptions must be goal-directed.
Right, we can't just hand out blank bottles of exercise anymore.
Exactly. If a patient's main priority, say they are in the early CKM stages, is improving daily fasting glycemia or aerobic capacity, then prescribe aerobic exercise. But if the goal is reversing sarcopenic obesity and preserving lean tissue, you prescribe resistance training. Ideally, of course, they are complementary.
They really are two sides of the same coin. Which actually leaves me with a final provocative thought for you listening to mull over.
Ooh, let's hear it.
Since cardio and resistance training trigger such distinct complementary physiological adaptations, one favoring mitochondrial capacity, the other favoring structural muscle preservation, how might researchers eventually design the perfect week of sequencing both modalities?
That is the million-dollar question.
Right. How do you maximize this polypill effect without causing overtraining in a compromised patient? If you do heavy cardio on Monday, does the fatigue ruin your muscle-building signal on Tuesday? Figuring out that optimal sequence is the next massive frontier.
And it will probably rely heavily on real-time tracking of inflammatory markers in the future. It's going to be a fascinating space to watch.
Totally. Well, we've covered a lot today, but I strongly encourage you, the listener, to read the full article in the Journal of Sports Science and Medicine to explore the specific exercise dosages and methodologies they used in these 23 trials.
It's an incredibly rigorous paper and definitely worth your time.
Absolutely. And hey, make sure to follow the channel and turn on notifications so you never miss an in-depth scientific breakdown of the sources that matter most.
Thanks for listening.
See you next time.